This is the last episode of The Amazing Race.
Thank you.
Thank you.
We're gonna cry.
As you walk into this room, this is going back in time. You are now officially in 1940. Okay, so a lot of this furniture is actually original to the observatory. This thing here is a demonstration tool that I used in my astronomy classes until 2015 because I did not realize how old it was. This was built in 1938. Right? Look what's happening now. The moon is disappearing into the shadow of the Earth.
Lunar eclipse.
Right, so that's a lunar eclipse. And then 2 weeks later, the moon is casting a shadow on the Earth, so that's a solar eclipse. Right? People are like, yeah, but wait a minute, like eclipses are so rare, so what are the odds that you get a lunar eclipse and then 2 weeks later a solar eclipse? The odds are 100%. And so the reason why we don't have eclipses every month is because most of the time, if you look at this full moon, the moon's orbit is tilted with respect to the Earth's orbit around the sun. And so most of the time the moon is too high. It's too high to be in the shadow of the moon, or it's too low so that the shadow of the moon goes below the Earth. And so that means that the moon needs to be located near these points here. Those are the intersection of the moon's orbit with the Earth's orbit around the sun. And so when it lines up approximately, that's when you can have eclipses. We are now upstairs where we have our dome and also our big telescopes. So
That's very big. I don't know what I was expecting.
Huge.
this is our flagship telescope. It's called the 10-inch refractor. This one is now the largest refracting telescope in the country that is accessible to the public.
Oh, okay.
This is our observatory assistant, Frederica. She likes dancing.
Me too.
Yes. We can be besties.
That's entertaining except for at night when if you're alone here. At night that goes on, I will cry.
How does the observatory work? Like, how does it turn?
The dome can rotate 360 degrees.
Sci-fi movie.
Sci-fi.
With this chain,
Oh, okay. It's all manual.
we're gonna go outside. So if you look at the sun, what you see is like an orange ball, right?
Yeah.
Yep.
You may notice that there's like very small black spots. There's areas that are a little bit cooler, they appear dark. So those are sunspots. They're small from our point of view, but they're actually twice the size of the Earth. So now this is our special solar telescope. You'll see a red ball in here. There's very faint flame shooting out. That's how it looks like.
Oh, that's so pretty.
So what we're looking at is glowing hydrogen gas.
It's like smoke coming.
Yeah.
Wow, that's so cool.
So for the stargazing tonight, what do we need? Clear skies.
Oh, it's looking mysterious.
This is like real sci-fi movie vibes.
It is.
If you look at the colors of the rainbow, we have Vibgyor colors. The bluer the color, the more scattering it undergoes. The redder the color, the lesser the scattering will be. So when you're doing nighttime observations, the sky is really dark. Your eyes have to be really adjusted to look at fainter targets. So the lesser the scattering there is, the more easier your eye will be able to spot fainter targets in the sky.
We're looking at a star called Arcturus. It's in the northern constellation of Boötis. It's about 36 light years away, and it's about 200 times brighter than our sun.
Wow.
That one's really bright. Do you see that one?
Yeah.
We can figure out which one it is actually. So that's Vega. Vega?
Yes.
That's so cool.
It's pretty bright today. So being out here and just looking in the sky really reminded me of my childhood, because that's what I used to do.
Totally.
Thank you so much. Like, we've had like the best time today.
This is the last episode of The Amazing Race.
It was really like a treat for us.
Thanks for joining us for the amazing race for the past few months.
This is the first time we visit each of these 4 spots. Like, make sure you explore more than we did.
Explore campus. It's
Yes.
a beautiful campus.
Catch you later, Western. See ya.